Hola. Um, I'm making a video about handlebars because that has been the topic of my most recent week. Um, I'm I'm redesigning my handlebar fixturing, and I've done this several times. This is like everything else. We keep iterating and figuring out new and better ways. And this time I kind of jumped the gun a little bit with making some of the tooling, and then I got real deep into it. And it's not the end of the world, it's just the tooling that I currently have. Here, I'll grab this. There's some stuff there. This isn't the breadboard that I'll be using. I have steel breadboard in the shop. This is some profile from Siegmund that's pretty cool. Nice aluminum extrusion profile, so you can build cheaper tools on the fly type of thing. But so we have the handlebar holder there, and I've gone to T slots, and that T slot to make a nice snug one for 80/20 because it's all 80/20 compatible slots. Um, Real pain in the ass because you're right at the edge of what's produced for T slot tooling. I'm still working on finding the best tool for that, but this is pretty cool. We'll talk about some improvements, but you can see, of course, the the pins there that just lock everything in place. Um, okay, let's start at the beginning. So here's the new bike. Hopefully, I get prints tomorrow. They didn't. They could have been delivered yesterday, but no weekend delivery for these, even though they're FedEx. So of course we've got some gull wing bars for this. It's a mountain bike, and a bent section there, reversed binder, some all that sort of stuff. So this is what needs to be made, okay? But when we make the bars, we have a goal, okay? Let's look at the goal, not this. Let's see, boom. Okay, we'll go to this. Okay. So if we look at our measurements here, the way the bar is defined within the bike, because of course I'm looking at these as full custom, full like development level bike, and the bars are designed with the chassis. Um, but I know a few things, and all of this stuff can be done with commercial bars, um, like you just saw there. Wherever that is, ugh, there's the bars, right? No, not there. Huh? I guess I must have hit them. Um, oh no, they're under here. Sorry. So we have commercial bars. This is a Surly um, Sunrise. I have all kinds of other bars programmed in here with various geometries. Of course, we can look at the width, the rise, the setbacks, and everything like that. So there's a few things we need to know about bars when we talk about them, but let's go into the frame here. Where'd it go? There we go. Okay, so I know where my hand grip position is. So for this mountain bike, it's going to be 835 from the BB at a 57.5 degree angle from the cranks. And you can see that we're dimensioned there. So that places my hands where I want them on this mountain bike. Then, of course, we need to know the sweep angle to horizon, and that's 20 degrees. I generally do 20 degrees on all my bikes. I'm sure somebody could get really fine-tuned on that, but I find that just a consistent parameter, it's better than everybody else, so there we go. So, of course, I need to know that I'm going to be using a 5mm stack, and this is the headset here. It's actually 5.3, but I'm not showing all my decimal points here because it gets too messy. So I know that I'm going to be using those types of things. I also know that the handlebar width. If we go over here, because this is just a elevation type view, if we go over to handlebar and stem PVD custom, 785 wide, and here we go, 18-degree back sweep. So that back sweep, this is the sweepiest I've done. So like, we'll see if that is helpful. 16s is what I've been using. 14s I did before that, and 14s were all right, but 16s definitely really started getting in the money. I'm wondering if 18's too far. We'll find out. Of course, I'm the only one I know that's checking this within this paradigm, and so that we really understand what decisions we're making. But 18 is what it's going to be. So we know a few things in relationship to the design of the bicycle. So let's hide this guy here. Let's go to this. So I made this calculator earlier in the week because I hadn't done one yet. So of course I have my calculator here that I use for my table math. This basically, I take in all my driving parameters from the frame, a couple other etc. there, and then fixture as it's set up, and it returns what in these black here, what I need to set up the frame fixture. And what's really cool down here, some really cool checks that I think every frame builder could use, where I can check these dimensions in the fixture and know my fixture is dead nuts because it's measuring just right as a bicycle or as a bicycle frame. But I wanted one for handlebars because I really hadn't done a calculator for that. And to do a calculator, of course, because earlier when I mentioned about this right here, this is where it gets really complex for most people. If we're locating the handlebars to the bottom bracket, and that's what's critical here, we can't just have handlebars as a separate entity. They are truly in context of the whole frame design. So to have a calculator for the handlebars, I not only need to know things about the handlebars as in terms of positioning here, but then I actually have to know things about the frame too. And I've resolved this to these elements here so that when I enter those, I get, and I know my table raster here for some other stuff, I can move along in some various calculations. Of course, the primary ones for many people are going to be these green ones here. In that, here, I'll make these a little larger. Because this is essentially the unitized handlebar stem described within the system. I have XY parameters here. I have my handlebar end from the center. You know, I have some various information there that's kind of cool for understanding it. We can look more at that. But then also I have this stuff here where you see this intersection value. And I did some other calculations here. Handlebar intersection from the end axis. Because once we get into modeling handlebars, what we find pretty quickly is we're having a hard time connecting the grips to the bike, and we need some way to connect them, right? Well, because all handlebars, I mean, you could make some hipster crap that is straight, but all handlebars have a point at which the handlebars meet. And what it turns out is that that's a very useful point for describing it in a system. So I can get that math going, and I can just, because I know the width, because I know the angle, and I know where the end position is, I know where that intersection is, and I know the roll angle. I know where that intersection is. Well, and also if I know the rest of the frame and where my hand grips ends are from my bottom bracket, I know where my steerer is, or the base of the handlebar assembly. And because of that, I can connect the two. In this case, it turns out they're 5 millimeters away from each other. And in this setup, you're going to see this value becomes very important in terms of the precise mitering of those handlebars. But let's get into that. Okay. You can tell this is a big topic, so I need to... Okay. One of the more useful things that I've done in my modeling is create a master part. Okay, many people use master sketches. I'm not a big fan of sketches because I find that sketches tend to fail. Here we can show all of our geometry here for a handlebar. Okay, so looks crazy, huh? Okay, so that is what's going on behind the scenes for a handlebar. I'll make most of this go away, but you'll be able to see. Let's do these axes, show, and we can talk about this intersection. I hope that's visible. Intersection axis. That's an axis across the point where they meet, and there's that other point there. So there's the axes. Let's make those visible. We actually don't need this horizontal one. Well, no, we'll do that because those are all, if you notice, calculated. Okay, so I'm calculating various positions, and then I can get my steerer axis here, and we can look at exactly how that goes, right? So if you look, there's actually, oh, look, there we go. So that's kind of what we're doing from the side. We've got this intersection axis here. That should probably be a little smaller. Let's make that smaller. Okay. And then we normalize it to the steerer and call this one the new axis because that's the distance apart. And if we do a measure, we should see those are 5 millimeters. There we go, 5.6. So that's really helpful when we start mitering. I'll just show you the math here. SolidWorks gets very slow once you start using equations, but once you use equations, you can do some pretty powerful things. But you'll notice that there's some big math going on there. So I shouldn't get too crazy with this. I enter some various things about the bike, and then I do some crazy math to get these various points. Okay. Well, I did these calculated ones directly right there, right about, oh no, I deleted that. Okay, so anyway, I construct it and I do it mathematically, and if they confirm I know my math is good, blah, blah, blah. Okay, so this is what we call the master part file. For the geometry, I do a similar thing for the bike frames themselves, and that gets brought into, let's bring this guy up. Okay, so here's the product of that. Now, I'm still developing a lot of the improvements that you see, and you can see here, there's my master handlebar equation in an assembly, and then I have my this is the assembly where I get to add grips and my data plate and all that sort of stuff. Let's go to the sub menu here. No. Okay, I guess we're going down into this one. If we go down again, wait for this. I guess I put the data plate in here as well. You can see here, I've solved a bunch of stuff with equations and made up a bunch of geometry in the part. And I'm not sure if I'm going to leave that there, but the thing is, I want to, actually I'm not going to. I'm going to bring everything into the master part. You don't get to see how the master part's really used powerfully here. It's just in an assembly, but it does get used pretty powerfully. Because we have these complex miters over here. These are a pain in the butt. Let's open that file. So we've got a bent tube and a miter that's at a crazy goofball angle. We've also got this tapered end here, which makes the bars look a lot better, but that's a hellhole. Yeah, how do we hold that and get that miter so that the whole assembly works out? Well, of course you can miter the part separately. If I had laser mitering done for me, sure, no problem. I don't have to worry about all this stuff, but I'm not having that done. I'm gonna cut them myself. And I'm learning a bunch while going through all this process. If I was doing laser, sure, but I'm not. So let's start thinking about that. How can we cut that tube precisely? Well, we've got a several axes cut. We've also got to have the lengths just right, otherwise it won't meet evenly on the binder. I mean, that's another thing. I'm sure there's some people that think they can cowboy up and hold that sucker and make that cut. You've got 2 axes or 3 axes that have to be aligned, and then the distance has to be right too. Because if you get the angles all perfect, but the distance is off, now it doesn't meet correctly, or it's obvious up here that it's off. You've got some real problems. So a lot of things have to come together. Okay, now what? Well, let's go back. This is the whole assembly with grips. We're going to go back to the handlebars. I mean the fixturing that I use. And I think that was over here. No. Oh yeah, that was that version. Okay, here we go. We're finally into the money. Okay, so here is my setup on the mill. Of course, this is a section of Build Pro plate with a 2-inch raster of 5/8. And then these couple of these little guys on there. And you know, the tricky thing is here, it's easy to make something like that held that tube if you're just doing a one-off. But if you want it to work on a number of handlebars, and I've made a bunch of different ones of these, you need to be able to place that precisely. There's also some measuring to get the lengths right. If you notice, there's a pin here that you can measure to the slide so that both sides are even, which is nice. If you notice, we mark the tubes where the bend is, so I can place the bend just right in there. And I can really accurately place that according to CAD. Now, this seems pretty wild, but it's pretty simple stuff. Most of these are Lego blocks. That's the thing about this system, is there's a lot of steel in here. These are 2, 3, 4 blocks. This is a Build Pro 4-inch by 4-inch block or whatever it is. Build Pro plate. These are the Build Pro magnetic lugs. We're in a standard milling vise. It's a Kurt, but you know, same 6-inch vise everybody has. And we have to place it at an angle. Now, anybody that's mitered tubes wouldn't have a problem placing that at a specific angle. In this case, because this bike has a 68-degree head angle and the bars are 20 degrees from horizon, and oh, and also with this tooling, the bar plane is the tooling reference. So it's all according to the sweep plane. The sweep plane is the one of the primary elements there. And then I told you about the intersection point that I'm gonna, like in the math, it's five millimeters away essentially from that intersection point. But of course that intersection point assumes I'm looking straight down at the table. But now I'm not. How do we deal with that? And that intersection point's underneath all this complexity. I'm going to show you how. It's pretty cool. What we're going to do is make effectively a tooling ball. I was doing this with a cone before, and now I'm gone to a ball. It's much more accurate and solid, and it's a killer tool. And you're going to see something really neat in a second that makes use of this kind of method too. But this ball here is 2 inches from this plate, which, or is it 2.5? Whatever the bar plane is, you know, when we say distance from the plate, if you notice the center plane of the bar sweep and this ball are coincident. The ball is exactly 2 inches away from that point. Well, that's handy because if we're sitting here at 42 degrees and that's 2 inches away, I know exactly how to cross that intersection line. If I go back to my calculations, that ball is 37.75 millimeters away from the intersection point if I'm looking down at it at a 42 degree angle. And then of course, since the cut that I need to make for the steerer is 5.06 millimeters away from that, I add the two together, I get 42.81 millimeters from, you guessed it, that ball. And of course I can just simply, in my mill, find the center of that ball, and once I'm zeroed on center, I go that 42.8 and boom, there's my miter. So I'm precision locating that cut and I'm holding each part of that system in place. And this slidey doodle thing that you see over here, what that's there for, and that of course gets removed during the cut. But when you're placing these parts here, you need to know that they're going to meet right at the same place and that they're clocked in the right position. You don't want them swaying around like that. So I have this little, it's like a jack, but it's more universal, and it goes into a sliding plate there that I can just, from CAD, find out where I need to be there. It's probably too tricky to calculate, but I've taken care of all the real money shots, and this is just kind of a fussy little thing that we do to get fancy there. So that's clocking everything correctly. And if since we're so close to the miter there with that disc, that, well, let's look down the miter. It's kind of like that. So since we're so close on a visual level, and for the welding and everything like that, it's going to look like they're meeting at exactly the same point on the steerer. So we've solved that problem. And let's go, okay, let me look at this again. This is a big monster of a project. I'm using Paragon 2-inch blocks for the 1-inch tube that holds my titanium bar ends. I have drilling here so that I can use the 1 3/4 inch blocks that the 7/8 tubes have, because maybe you want to just fabricate something entirely out of 7/8. You can do that here. but I'm starting to think I'm just going to make 2-inch blocks for 7/8 and not even deal with this smaller thing. Because one thing that does happen is the center plane height changes. Maybe I could make some little spacers or something like that. But the center plane height changes, and then everything starts becoming whole separate toolings because I didn't make new blocks. So maybe I'll make new blocks. Anyway, we're pretty elegant here in terms of what happens, and there aren't really too many custom parts here, and a lot of these have cross uses. Let's look at the welding of this. Okay, so this is just at the machine. Well, there's so many huge benefits from using the fixture plate material. I mean, it's a ton of steel, which is awesome. We love that in the shop. But the fact that this tooling that exists for my mitering can get carried over to my welding table, bolted down, and now suddenly, let's look at this configuration. Oh, come on, ruining my whole show. I need a faster computer. Here we go, welding. Okay, there we go. So we go over to welding. Now, this isn't a whole Rhino cart surface. This has been appended for visual ease. But we have another block from Build Pro here. We have this funny little holder for the steerer, and that's got some bronze in there too, so we can just clamp our steerer lug there. And the thing is that you don't even remove these tubes from these blocks, or if you needed to, you could put those other alignment systems in and reclock everything in position, no problem. But let's say you didn't take the tube out of the block, it just remained there. You just bring it over to the welding table, clamp it down, and place this guy in there so it fits right into the miter, clamp it on some side plates, and you're done. Now you could argue, oh, I'm losing a fraction of a millimeter by not locating this specifically the base of the stem. And you'd be right, it's trivial, but there's a reason for this method, is because I'm generally maximizing the amount of space or trying to utilize the space that I have in these miters when I'm modeling. So I've got some tricky welding to do, okay? And the thing is, there's not much space on either end, and it becomes more important at the welding table that I actually end up with a good distribution for my welding. Now, let's say I did lose some accuracy, and you're striving for that less than 1 millimeter difference that was lost in that. Well, rest assured, you can use a 1 millimeter spacer above your headset if you'd like. I'm already way ahead of the game here. So we have some remarkably simple tooling that's reused from mitering to welding, positions everything extremely well. But there's something even cooler. Okay, this is what I will be doing, obviously. But there's the sign bar setup. And some people who've seen the past work have seen that I've already basically set up a sign bar with tooling like this so that I can get that precise setup on the weld. And if you look here, now I've got a miter or a welding setup right there. So vertical like that, I can set up a stop for a certain height for the base of that steerer. That's some easy math. What's slowing this process down, and this is a sign bar, so right there I'm set at 42 degrees on the table, and I've got my parts set up there. I need to make this tool, and I should probably just buy another plate and send a hole through it to allow adjustment on the top. The problem is it gets into an area that's pretty cluttered right there, and that's to pull this sign bar flat down to the table. Yeah, it's a really cool tool. very precise, obviously. Um, I've made these parts. I've shown the sign bar setup. And of course, that type of tooling is what led to this, or is how we get this tooling block here, for very precisely centering a ball and placing a ball at a certain distance. That's some basic machine shop stuff. But this is a really cool tool. One day I hope to use it. But I'm like 90% there. The last 10% is really what's expensive and time consuming and not something I have a mood for. But there's a simple adjust that uses some tooling chain. Tooling chain is some really cool stuff, and it effectively gives you tension that's very flexible in one plane. Um, yeah, so this was updated and everything. Um, let's go back to milling. Okay, so that's what I'm doing. Now, let's talk about what others are doing or should be doing or something like that. Um, I have a blog post here, bars, stems, and spacers from 2019. Okay. In that blog post, I talk about how do we measure commodity bars and what dimensions some are, because, when we're like, let's take ourselves out of PVD land where he's making crazy stuff. Let's say you have some Atlas 1.25 risers. Well, you can see here that that's not actually the rise. And we have some dimensions here of 53 setback from the center here to the end. I can see my dimensions if I have the bar set up to horizon there. Some basic information like that. And of course, nothing happens in a vacuum and all that. And we have our stems here. Stems get rotated. This was back a while back, so it's a 65-degree head angle here. In today's money, I'd be doing 68 on a mountain bike because we've been moving much steeper than we have in the past for modern mountain bike design. But that's approximately the dimensions. And then, of course, we can look at it as a system here. There's some various comparisons of handlebars in stems at 20 degrees. What sort of positional difference does it make if you use spacers or no spacers or rise bars or flat bars or anything like that? So this is stuff that's pretty easy, can be done in bike CAD in some ways, it can be done in rudimentary CAD, but it's definitely, if you're going to be into the handlebar space or the high-end custom type stuff, you really need to know this because, of course, when we get to, where's my drawing? There we go. Oops. Oh, I didn't do it. Why didn't we pull it up? Oh, is it doing it now? It's gotten all lost. There we go. Yeah, we need to know that stuff. Well, I mean, there's lots we need to know when we're doing a bike, but we need to know that stuff. It's mainly here, and you have to connect that to the chassis. We can connect the grip end to the bottom bracket using these numbers. We need the whole other chassis numbers to get to the base of the stem, and then we need to know that stuff. And you can use commodity parts, but you gotta know that number right there, and that takes some testing, some evolution. There's some other ways I've tried to work on it. Okay, let's see. There we go. So these are cool. I have a crossbar. We'll talk more about these bars. I have a crossbar. I kind of like it. It makes me think of BMX or moto, but it serves a purpose in that I had a handlebar failure. My one welding failure I've ever had a year or two ago, where this broke off. Because that's a tough joint. And I decided I'd add a little insurance And because I can 3D print a fancy thing there, I've got that. This assembly starts at the top of the headset. I've got my that's the model there. I've got some grips and stuff, but let's go to this. We're really trailing out here, and I know nobody watches past the first 30 seconds anyway. Okay, well that's not coming up, or maybe it is. Anyway, there we go. It's cool. I put a lot of work into it. I've refined it a bunch. There's probably going to be some more refinements, but that's it. Okay. Cool. So tomorrow, bike starts in earnest. I get my prints tomorrow in the shop. I make some more tooling. I bend some stays, and then Tuesday, cleaning up prints, starting to fit everything together. It's going to be cool. A lot of cool new tooling in the pictures. All right. Bye.